Okay, so I've made a little model. Hopefully it's still going to work. Let's show you the first bit. I'm going to show you how they grow and show you the spirals. So first of all, so if that's an axon, first of all, you get this cell, you get a myelinating glial cell, and it comes and sticks to the axon, and it won't be big enough to wrap its whole way round, but to start off with, but it will wrap its way round, and then it will keep growing until it laps over itself, and inside itself, as it wraps round, it will create, that's water, that's cranial C. It will create a body of cranial C between itself and the axon. And it keeps growing. It will just keep wrapping round and wrapping round. And as it wraps round, it will stretch out. And each time it grows a bit, it filters more cranial C into itself. So it gets two spirals. It gets a spiral of membranes and it gets a spiral of cranial C. And it spreads out, not just the sides and the front, but this whole middle bit spreads out. And what you end up with, here we have a bigger version. So you only see the outside. When you look at them, you just see this, it's thinner now. The axon is much thinner. And this, you only see the membrane, but inside there's two membranes. There is the membrane, one spiral, and then the water, the cranial C, the other spiral. And I'll go to the side, and as it unravels, it gets narrower. See how it's going in towards the middle? It's getting narrower and narrower and thinner. And every time it turns, this bit here connects to the axon. So around the axon, you get this spiraling of connections into the middle. And oh, there we go, I can get it all in. So in the middle you'll end up with this big kind of area of just water in the central kind of cavity in the middle, and then it spirals around that, and it can spiral over 100 times, and each time it keeps spreading out along the axon. So I'm going to roll that up again, and when it's all together, all the time it seals to itself. So there's tight connections as it's sealing it to itself. There's tight connections as it seals to the axons, and you can only get pure water with nothing else will come in through a tight junction, and then to feed itself, it will pull in oxygen, glucose and salt. So it ends up with membranes and cranial C inside, and there's this big area of water in the middle, or cranial C, and then up to 100 spirals of cranial C, and it's about 50-50. Right in the middle it's about 50-50, but if you come, excuse me, really turns me on, I'm even dribbling as I'm talking about it. So the middle you can have 100 spirals. When you get further here, see, this will only be 50 spirals, so there's much larger water content. And then you get to the edge and there's only one or two layers, but it's still the same thickness. So this area is nearly all cranial C, so you end up with a reservoir of cranial C at both ends on the outside. And then you end up with a reservoir of cranial C right in the middle. And as you get another one growing here and connecting here, and then thousands of tentacles joining one to the other, so the cranial C will be flowing down through the nerve, and it can filter in more water, oxygen and glucose from the environment around it, which is the interstitial fluid, but much easier to take pure water, oxygen and glucose from the myelinating glial cell before it, because it's already moved. It might want to take out a bit of carbon dioxide, but it's got this flowing down, and that way they just flow one to the other to the other. And even this is still, oh, how wide is that? It's a couple of centimeters. So if this one was this thickness, if this glial cell was this thickness, it would be about 2 or 3 times the length. So be 2 or 3 times that length before the next one, before the next join, and then so it's a long way before it has to connect, and then this is traveling down through the nerve. So from the outside you see it as solid, and people think of it as solid, but it's actually much more water or cranial sea than it is membrane. I'm going to unravel it actually and then just show you, because we just see the membrane, but you can take the membrane out, and you can just have the layer of water. Whoops, come on, it doesn't want to separate. I made this special effect for you today, and I'm still trying to understand how to work it. Or you see, cranial practitioners, they will just tune into the cranial sea, and you can easily do that. You can just feel inside and just feel the cranial sea if you want. You don't have to feel the neurons or all the other things. You can just tune into the cranial sea. So with a myelinating glial cell, you can tune into the cranial sea within it, or you can tune into the membrane. So if you're tuning into the cranial sea, you will just get this spiral of cranial sea just moving out, and it'll have a much more delicate and channeling type effect to it. So you can just channel and feel the cranial sea, or you can feel the membrane of the myelinating glial cell, or you can feel both. This is only this is only taught by me, by the way, and this is a theory. The actual makeup of it is accurate. It is that much fluid, and it is that much membranes, and it is that many spirals. The energetics of it that I'm describing and what that fluid is inside is a theory of mine, because I could feel it. I could feel it. I could feel the cranial sea traveling off down through the nerves and staying as cranial sea. So I investigated to find a way that it can do that, and that's opening up a lot in the cranial web where now they're saying, yeah, it flows off down through the nerves, but I haven't seen people saying how it can do that and stay as cranial sea. And this shows how it can travel down the nerves and still be cranial sea. And also all of the other places that cranial sea is produced in the brain, from the capillaries. It's produced by the what they call not the ependymal cells. Well, in the choroid plexus, it's filtered through the ependymal cells, and it's got tight sections, so only pure water can come through those connections, and then the rest of the water comes through the cell, and the nutriments are released through the cell, and only those nutriments. And then within the endothelial cells around the capillaries, same thing, they have tight connections, and they only let out pure water, then oxygen, salt and glucose is let out. These also have tight connections, and the only reason for a tight connection is that it's only going to let pure water in. So I think it's a filter, the same as those others. And this will be our next group next week, where I'll teach you how the endothelial cells work, how the ependymal cells work, how they filter and make the cranial sea. And rather than calling it the blood-brain barrier, which is a terrible name, we're going to call something like, I don't know, the waterhead or the spring head that is creating all of this cranial sea easily. And then we'll show how the filter of how it travels out through the nerves, and that the interstitial fluid from the nerves can't flow back into the central nervous system, because there's this flow of cranial fluid continually flowing out through the nerves, which stops stuff flowing back in. But we'll do all of that in the next webinar.